How you doing, everybody? Randy Richard in the shop, and today we have a Tacoma, Toyota Tacoma output flange from the transmission to the rear drive shaft. This is off my son's modified truck. I've shown that in previous videos. Anyway, he blew out the U-joint on it, jumping in the desert. What we're going to do is we're going to make an adapter plate that will be between this huge double U-joint. This is a 3/4 ton Dodge U-joint, and put those together, right? Like so. We got a 1 inch, 5 inches in diameter piece of 836 plate. There's a plasma cut from some other part, obviously off of eBay. It's just big enough. Wish we got a little bigger one, but it will work. I've already modeled this up, and then the drive shaft, the drive line, it will be cut and machine the ends of it, and we'll put it on here and weld this on and such. So my part of this is to make the adapter plate. That's what we're going to do today. It's not too difficult. We'll have through holes for the bolts or the studs that are pressed into here, and recessed counter bores for the nut, and then offset will be the flange here for bolts coming through. We'll use 7/16 20 bolts that will pass through here into the plate also, and it all works out. I'll show you a model of what we're going to make. This is the monitor I have right out here in the shop, right by the lathe. I call up my drawings out here instead of having a piece of paper, even though this one I did print just for the file right there. And I keep files on everything I draw. But this is the plate. We'll be able to do all these processes from one side. We have 4 holes that will be drilled and tapped for 7/16 20. We'll just drill those through. And then these will be counterbore holes here for clearance holes for a 7/16 20 bolt. And you'll see over here there's the counter bore, and we've already figured this out for thread engagement of the bolt and all that. So for length, so how deep we had to clear the nut and give us enough thread engagement into the plate for the depth of the counter bore. And we made the counter bore is going to be big enough to use a socket on to reach into the hole. So those are 7/8 counter bore. Pretty much that's it. Like I said, we'll be able to do this in one setup, and from one side. We'll use the DRO for the bolt hole pattern. We know the diameter of the bolt circles, and just 4 hole patterns. Pretty cut and dry. Lance lathe. Now this is my 4-jaw chuck in here. This is a 10-inch 4-jaw, and we have the puck in here. Use the smallest diameter, right, of the puck. This is cut with some draft to it, and it's not about half to 3/4 of it have draft on the angle when they cut it, and the other side, and the breast is straight. So these circles on each side don't line up with one another. It's not a parallel sided piece. So, and it's plasma cut, so it's fairly round, but it's not even on the sides, right? So I took one side of it, I chose the roundest side and went around and marked it, and marked the center and center punched it. So now I have a center punch mark in there. And what I've done is I took a wiggler in my tailstock and poked it into the center punch. And then I put an indicator, a test indicator, on the top of the shaft of the wiggler. I proceeded to center it up. Right now, what the wiggler will do, the wiggler will move around. It will go up and down or sideways if the piece is not centered. So as you can see here, we're reading less than a half a thou on this. This is a 1/2 thousandths test indicator, and so I'll be pretty happy with that. We'll go with that, and like I said, we're going to put a hole in the middle, turn the outside, and be good. We're gonna clean up this edge part way, 1/4 inch or so, taking light cuts just to clean it up so it's round and concentric. The outside edge will clean up, and then we'll be able to flip it around and then clean the rest of it up so it's a parallel sided piece. And I hope to get 4.950 out of it. That's what I'm hoping for. I hope we can clean it up and still maintain that. I'm going to ream it to a 1/2 inch. Hopefully. All right, set up back in the forge jaw. We got soft jaw copper pieces in here on the gripping surface. We dial indicated in on the center hole as far as concentricity goes, and we have a face indicator also. So we're really pretty darn good here. Looks really good. And we're going to do the turning on the outside again here, and just get it cleaned up even with the other one. And we're looking real good. I was shooting for 4.950, and I ended up at 4.944, so 6 under that. So that worked out just fine. I laid out some lines to estimate where all the holes will be. So I put in some 1/2 inch little aluminum blocks to support the piece. So I have clearance underneath, and we're just doing an alignment. We're sweeping the outside and getting her set up for setting up the DRO. We're looking good. Within a half thousandths.